Okay, guys, so this is standard 1B where we're going to solve a proportion. Now, if in the first two problems, we're going to just have a proportion, but it's important that you recognize that what you're being asked to do is you're either going to solve a proportion or you're going to set up and solve the proportion. If there's not a proportion set up, you don't get credit, because that's what this says, is that this standard is that you can set up and solve a proportion. That's what you're proving on this part of the test. If you do any other methods you learned in 6th grade, just simple division, if you're not setting up a proportion for this, you can't receive credit. Okay, that's what you're proving, is you know how to set up a proportion. So these first problems, and again, it says right here clearly, you have to show your work. So please show your work. Okay, so if we're looking at how to set up a proportion and solve a proportion, then when we look at this first problem, what we've talked about is you would do a cross product equation. Now we've also talked about how to do scale factor, where you could look and say that this is 6 times 8 is 48. What times 8 would give you 36? Now, so it's not going to be that easy to see. So it doesn't always work well to use scale factor. You could solve for t by multiplying both sides by 6, because t is being divided by 6, and we undo that by multiplying both sides by 6. But I'm going to stick to one method. If you can successfully do one of those other methods after you've set up a proportion, I'm fine with that. But I'm going to show you one method just to avoid any confusion. So what we're going to do is we're going to use the cross products, which if we have A over B equals C over D, then we can say that A times D equals B times C. We can say that if we have 3/4, and we know that that's equal to, let's say, 9/12. And we could see that. We plug in a calculator, it tells us their equivalent. When we multiply their cross products, we get that 3 times 12, and we get 4 times 9. Each one of those equals 36. And that's true with any two ratios that are proportional. So we're using that to say that what we'd have is 48 times t would equal 6 times 36. That means we have 48t equals 216. Then to solve that, it's 48 times t. To undo the multiplication, we divide by 48, and we get that t equals 4.5. And if we look at that proportion, we started out with something over 6 equaled 36 over 48. And we're going to put 4.5 in there. It kind of makes sense, because if we look and we're comparing, this number should be less than 6, because 36 is less than 48. And this number should also be less than 36, because 6 is less than 48. And this should be a scale factor. This is a scale factor of 8. And so this has to be a scale factor of 8. So that works. 4.5 is the solution. So what we just did was, first of all, we used correct principles. We looked and we said, we have this expression. We're going to do the cross products. So we wrote out the cross product equation. Then we solved for the variable. And then we checked it to make sure. And the way you would check this, you don't have to check this for the grade, but you would just look and say, well, what's 6 times 36? And is that equal to 4.5? times 48. And 4 times 5, 4.5 times 48 just so happens to equal 216. And 6 times 36 was 216. So they are equivalent. But what we were after, what we were trying to find was what would t be? And t is 4.5 to make this proportion true. Okay, so now we look at this one. We're going to do the same thing. First thing we're going to do, write out our cross product equation. So our cross product equation would be 0.5 times W would equal 7.5 times 0.8. So then we'd have 0.5 times W equals 6. So then our next step, we're solving, we're going to divide both sides by 0.5, which means W equals 12. Now, if we look, that kind of makes sense. Because if we were looking at this, if we put a 12 in here, we look, 0.5 is less than 0.8, 7.5 is less than 12. Okay. If we look, it's not quite doubled each other, and those aren't double each other. We could look at scale factor, but ultimately what we're going to do to check is say, well, if we have 7.5 over 12 equals 0.5 over 0.8. If we did the cross products of those two, we'd get the 12 times 0.5. Half of 12 is 6, and 7.5 times 0.8 is 6. So they are equivalent. We have the right answer. So again, what we did was, first thing, we drew out, here's our cross products. Second thing, we did the cross product equation. Third thing we did was we solved for W. Now what we're going to do next is look at story problems. So how would we make story problems? So how would we set up a proportion in the story problems? Because that's the hardest thing. And the story problems we're going to use, you're going to want to make sure you're looking at it. How are we setting up this story problem? We're going to first set up the proportion. And we're going to use what we were using with the unit rates. We're going to set it up just like we did when we were talking about unit rates. So when I look at this story problem, as I look at this, I'm looking for what's important. So the first thing I see is it says he uses 30 pounds of ice melt to cover 5,400 square feet. And they want to know how much ice melt, which means I don't know the ice melt, to cover 7,200 square feet. So what we're asking is how many pounds per square feet, basically. So we're going to set up first our proportions. This is going to be our units. And then we have this proportion. So we're going to list our units here to the left. This is our reference ratio, which is the information they give us, pounds per square feet. And this is our problem ratio. In other words, this is the proportion we have to solve. And so they're only going to give us one part. So again, we look and we say, well, what are our units? We're doing pounds per square foot. So we're going to have pounds per square foot, which means this needs to be pounds, this needs to be square feet, and this one needs to be pounds, and this needs to be square feet. Same units you have on top. They're telling us what we're comparing. And so what we're going to stick to is we're going to have a unit rate with this. So we're going to have pounds per square feet. And I notice some people will go to the unit rate, but make sure you're writing out a final proportion. And you're actually doing more work than you have to. Because if we look, they first tell us that we have 30 pounds. So we have 30 pounds for 5,400 square feet. And they want to know how many pounds of ice melt, so we don't know this, for 70,200 square feet. So 70,200 square feet. All right, so now we've got a ratio. We've got to solve for x. So what we're going to do is the cross products. So we're going to write up a cross product equation, which says that we're going to have 5,400 times x should equal 30 times 70,200. So this becomes 2 million. Okay, so this becomes 2,106,000 equals 5,400x. And so we're going to divide both sides by the 5,400, which means x equals 390. Now, of course, we're being asked a question, so we have to write an answer out. But if we look, we were trying to figure out what is our solution to x, and that's how many pounds. So what we just answered is we need 390 pounds to cover 70,200 square feet. So that's how we write our answer. You need 390 pounds and then we're really just going to rewrite ice melt to cover 70,200 square feet. Ice melt to cover 70,200 square feet. Notice we're pretty much using the same words to answer. We're just plugging in what we came up with for our solution. Okay, so this is, again, what we've done is the first thing we did was we set up our proportions and wrote our units. We kept pounds on top of each one of those ratios, and we kept square feet on the bottom for each one of these ratios. Okay, once we set up our ratios, then once we had our proportions, then what we did was we did the cross products. We did the cross products here. We solved for x, and we wrote our answer out. Those are the steps. Okay, so as we look at this one, again, what we're going to be looking at, what's the question? It's how many parts can the machinist produce? And we're looking for our information. Their reference is you can produce 702 plants in 18 minutes. How many can we produce in 45? So we'll set up our proportions. So we'll have our units, our proportion written out. We'll look and ask ourselves, what are the units we're using? We're going to do plants per minute. So we're going to put plants here, minutes on the bottom. So that means we're going to have plants here, minutes on the bottom. Plants here, minutes on the bottom. Now, if you're a student that's watching this video now because you didn't do well on the test, well, then you should make sure you're doing this right, because you're watching this video because you couldn't do the problems. And so if you set it up like this, I told you before, and I'll tell you that most students that got it correct set it up this way. So they followed the direction and they were safe. So now what we're going to do is, again, we talked about this being our reference ratio, the first ratio, and the second ratio is our problem ratio. In other words, it's the one where we're going to have a variable because we're trying to find it. So if we look, our reference ratio is right here, that we did 702 plants in 18 minutes. And we want to know how many parts or how many plants, so we have X, in 45 minutes. So the next thing we do is we find, so this is the first thing we did was we wrote this out. Second thing we do, we we put the parts in their place. The third thing we're going to do is the cross products. So we look and say, well, we're going to have 18 times X equals 702 times 45. So we're going to have 18X equals 31,590. Then what we'll do is we'll divide both sides by 18. We get that X equals 1,755. So we'd have that 702 over 18 would equal 1755 over 45. Well, if we look, this number is about 3 times, a little bit less than 3 times 18, and that, so 1755, our solution should be about 3 times 702. And it's almost there. So we want to check, I'm looking at it and I'm going to check my cross product. So if I check my cross product, then that means I'm going to look and say, I'm going to check my answer, and I'm going to have 702 times 45 should equal 18 times 1755. So I'm going to take the 18 times 1755 is 31,590. And I already did this math, so I know this is 31,590. But I'll double check. It works out, so I know I have the right solution. Now my answer. How many parts can the machinist produce in 40 minutes? Or how many plants is what it should say, because we're talking about plants here. So your answer would be, he can produce 17,055 plants in 45 minutes. So again, what we did was we did the steps. First we wrote out our proportions, then we filled them in, then we set up our equation, and we solved, and then we wrote our answer. The check you don't have to do. It just helps you understand if you got the right answer. And I would be putting it in there. Sometimes you'll see me say, really? Because if you're looking at it, your proportion won't make sense. So you put it in there to at least check to see, does that number make sense? Again, if I look, this is about 3 times, and 1755 is almost 3 times 700. So we're looking at about, because 3 times 700 would be 2100. And 3 times 18 would be 54, not 45. So, it's about that, okay? Okay, so it was very good to see. I mean, most students, if you follow my directions on this, you will not struggle. But those that don't will come out with odd answers. But the first thing you have to understand when you look at this problem, you have to look at this and understand what the question is. And you have to understand the parts of it. It says, if there are 1,440 students playing on the lacrosse, how many girls play? The whole question says, for every 17 girls playing lacrosse, there are 28 boys playing lacrosse. If there are 1,440 students playing lacrosse in the district, write and solve a proportion. Now that's key. If you have to write and solve a proportion. That's what it tells you to do right there, to predict the number of girls playing lacrosse. So one of the things you have to understand is this is total students. So if we look, we have 17 girls in our ratio and 28 boys in our ratio, which means our total is going to be 35 or 45. So when we set up our ratio, again, we want to look at our units, right? And what we're talking about, the 1440, that's the total. So remember, we're going to have our reference ratio and our problem ratio. And what people will do is compare the wrong things and put the wrong numbers in. But the 1440, that's the total. So if we're going to have total here, then we need to have total here, and we're going to write down here that we're going to have total on the bottom. And then we have to really pay attention to what we're asking, because they're asking us to find out how many girls play. So that means the top's going to have to be girls all across. Now, we don't know how many girls, so you might say we're going to use G. But we do know that in our original ratio, we had 17 girls for every 45 total. So that's our ratio. So with that, then what we can do is now we can set up our cross product equation. So we're going to have that 45 times G equals, there's 45 times G, equals 17 times 1440. So that means 45 times G equals 24,480. And all I did with that was just put it into a calculator. So now I'm going to solve. So that means I'm going to divide both sides by 45. And that means I'm going to get the G equals 544. Now look, I put the G there on purpose, so I'd recognize my answer is how many girls. So you might go back and check, because some people will answer for how many boys there are. But you go back and look. This is what they said. They wanted us to figure out how many girls. So we would say we're supposed to predict the number of girls. So we predict or you could say I predict that there will be 544 girls playing lacrosse in the district. Now later we're going to talk about where you would actually use these proportions. I mean, this is where, but we're going to apply these proportions when we're talking about statistics. And so when we get in chapter 9 and 10, we're going to use these again. So let's review. The first thing we had to do was we went in and we looked at our problem. We figured out what our question was. We looked at the reference data. We set up our proportion. So secondly, we set up our proportion. We're going to have those lines no matter what. Then the third thing we did was we plugged things in, plugged in our values. From there, we did a cross product equation. That's the fourth thing we did. We solved the cross product equation, and then we gave our answer. Those are basically the steps. Remember that we set it up with a reference ratio and a problem ratio. We set up the proportion. Remember, this says right here in blue, write and solve a proportion. You may be able to figure this out in your head, but the question is, can you write and solve a proportion to solve this? That you can figure it out in your head is wonderful, but what we're testing on is, can you see how this is applied in a proportion? That's the gist of this. If you can't do that, I can't pass you off on it. But it's a simpler way to do things. It's more precise, and you're going to see that it's going to carry off in the next year. It's going to carry on to what we're doing in percents, because a percent is a proportion. And if you can get practice at doing this now, well, then it's going to be a lot easier next year, and it's definitely going to be easier this next month. Okay, good luck on this.